Oh, yes, it's the Qualcomm podcast. I'm PJ, and thanks for listening. Qualcomm makes some of the best technology on the planet. I'm going to bring you interviews with the experts and the inventors here so you can understand how the technology works and find out what's coming next. Today's episode is part one of a two-part conversation about extended reality, aka XR. I brought in my friends from the XR team to discuss all the different types of realities, including augmented reality, virtual reality, mixed reality, and all the technologies that power these realities. Plus, we're going to get you up to speed on the latest XR headsets, so you can try it out for yourself. Joining me today is our head of XR, Hugo Swart. We've also got Hiran Bendi, who leads product management, and our director of product marketing, Leilani DeLeon. We've also got our buddy Justin Reed from our digital marketing team. When this team reached out and said they wanted to do a podcast, my initial thing was they probably want to talk about sneakers because this team has sneaker game.
Woohoo!
Right? Like I've seen the footwear on this team. We're not going to mention brands because I don't want to get in trouble with legal, but this team has strong sneaker game.
We do.
Yeah, we do.
Yeah.
Yes, we do.
Yeah, I like it. So, but let's get into what we're going to talk about today, extended reality.
Leilani, why don't you start explaining what is XR?
Wait, excuse me, Hugo, that's my job.
Okay.
So, Leilani.
I got this, guys. I got it. So, extended reality, we actually use the term XR. And that term is an umbrella term that encompasses all the different realities, whether that be augmented reality or AR, virtual reality or VR, or mixed reality, MR. If you look at X in that case, it could be the variable of, put an A in there for AR, put a V in there for VR. So it's that umbrella term that collectively talks about the different realities.
Okay. Walk us just through one at a time. So virtual reality, what is that?
So virtual reality is when you are immersed in an environment within a virtual reality headset. Your vision is occluded from the outside world, and now you've just stepped into a different environment virtually.
Got it. Okay, cool. And then augmented reality.
So augmented reality is when you put on headwear, whether that be glasses or another AR headset, where you can see the real world outside you and your vision, but now there are images that are overlaid onto that or augmenting your current real space.
Cool.
So now, maybe just to for it to be clear, I mean, many times we think about virtual reality, augmented reality, but think about just from a consumer perspective, right? Thinking about games, thinking about, watching movies in 360, thinking about Pokemon, flying in the room. But there's also use cases for enterprises, right? So we see a lot of enterprises now to use both virtual reality and augmented reality to increase efficiency, right? Training of employees. Not long ago, we saw Walmart, right, announcing that all new employees are first trained in VR before, serving customers.
Wait, really?
So,
I didn't see that. That's crazy.
Mm-hmm.
Yeah. I mean, there are more and more examples. So I think, while we talk about the definition of what is VR, what is AR,
right?
Think about the world of opportunities and use cases that we see in both.
Yeah, it's a cool AR experience that everyone's been flipping out over? Google rolling out an augmented reality experience inside of Google Maps. So
oh, yeah.
When you enter Street View now, you can hold the phone in front of you and it projects massive arrows. I'm like, someone at Google thought of me and literally was massive arrows for PJ.
I totally feel you on that.
Right.
Because, when you're using Google Maps, right, and you're outside, you're like, first of all, you have to figure out which way am I pointing and I have to move my phone around. But with the ability to use AR and actually, here's the pinpoint, and you need to actually go this way with the arrows, it really is helpful.
Totally.
Yeah.
No, totally.
But I also think that, people who don't think that they are not experiencing AR today already are. If you think about a lot of people using Snapchat and things that are overlaid and taking pictures, that's AR. That's a version of AR.
Even the stuff that's coming out on websites. But as far as Google's concerned, I think imagine that experience going from a phone to glasses.
Yeah.
All the information. The way, spatial computing as a term has been made so famous over the past few years now. And I think it totally makes sense because 30 years ago when
What does that term mean? Spatial computing.
spatial computing is computing in space. I mean, there's this whole thought process where we've gone through 4 generations of computing. First generation was in mainframes where, people had to go inside a specific room to do some sort of computation. And that computing came to your house on a PC, then which was the second phase. And then the third phase where it went to your pocket in a smartphone. And now we're talking about this spatial the computing coming in front of your eyes. Like the compute's getting complex, but the devices itself are disappearing because finally the interaction of the human body with the computing is through its eyes and all the senses. And if the device itself disappears and you see through the eyes, that's spatial computing.
Ah, that's cool. That's a cool way to describe it. Seeing like within the space in front of you, seeing the computing.
So the Google Maps, I mean, one of the things that I know Hugo and I, when we, as a part of our product meetings, one of the things that we always discuss, like Hugo's a big fan of this user experiences about holographic telepresence, like having this podcast. If Hugo was in Brazil and, we were in China or India, everybody different parts of the world and having a virtual, like wearing AR glasses and being able to communicate with each other. And the crazy thing is this is not even the future. We are actually working with companies and seeing these products happen in the next 12 to 18 months, right?
Yeah. So I think, as Leilani said, we see augmented reality a lot in smartphones today, but soon, and when we say soon, I mean, within, just a few years, you can expect to see these experiences in glasses, right? We see a lot of development happening, a lot of improvements in displays, in processors, and making the form factor right for mass adoption.
I just want to close up one loose end. We still have one more reality that we threw out there. I guess mixed reality.
Yeah.
Is it? No,
the thing is, depending on the company, depending on the person.
Agreed.
I think there's a different interpretation.
Totally.
The one that I like the most is when you have a VR type headset where you have everything enclosed, but you have a see-through capability, digital see-through with cameras. And then you have, so basically you see the real world through a camera in the VR headset, and then you have synthetic digital objects, right, in front of that display.
Got it.
So I see more and more of the VR type companies saying, hey, I want to add MR experiences, right, to this VR headset.
Right.
But I don't think that there is an industry-wide agreement on that MR. And that's why XR is always a great answer.
Right.
Because it's an X, and
it covers everything. And I think Leilani mentioned that we use the X as a variable, which is true.
Yeah.
At the same time, I'd also like to address that we got this term when we started working with Kronos. Like we work with Kronos very closely on now on OpenXR, but we worked with Vulkan in the past. This is a standardization body.
Okay.
And
for I'm sorry. So in Kronos, just so our audience, that's a standardization body for graphics libraries
as
software.
well, it's been famous because of the graphics libraries, but they're now doing a lot of work for VR and AR. And within that domain, they started calling. They actually coined the term XR as extended reality. So that's like 3 years ago or 4 years ago. I remember a few of us, including Hugo, myself, and some of the other folks, were discussing, is this AR? But we're going to work on VR. But then we're also working on AR. But some of our customers are also doing MR.
Totally.
And then one of our standard guys was like, hey, you should probably look at this term, and it just fit
we
the whole
help them
bill.
spread the love around XR.
That's true. That's true. I mean, 3 years ago, XR was not a term that folks would use. I still remember going to many meetings outside of Qualcomm where they're like, what's XR? And I would look at all these conferences, Augmented World Expo this year, and all these other conferences, they've started using XR as the default term.
That's good.
And another interesting way to explain XR is that we see that in a few years, AR and VR are going to converge. Right? So you could have one device, one set of eyewear head-worn device that you can do both VR and AR, depending on the context, depending on the situation. Of course, the display is the key. Once you have displays that are good enough to provide a wide field of view, digital experience, but also be in a transparent mode where you can see the real world. So I think that's the third explanation for XR.
The V sitting on the A becomes an X.
Okay, the fourth explanation.
I think you guys were proven right by calling it XR.
We know
If you
what we're
look
doing.
at the industry, I mean, majority of the players that are working on VR, they're also working on AR. A lot of the features that you need for VR, right? Perception features like tracking, eye tracking, hand tracking, body tracking, you need both for VR and AR. So there's a lot of overlap on technology and industry. So I think it deserved its own name.
Definitely.
Yeah.
You know, since you just opened the box, I mean, and we're going to jump into how long we've been in this, but is it fair to say that XR is the most computing intensive, I guess, experience out there?
I would think from a digital experience that we as human beings have.
Yeah.
Yes.
Yeah.
Right. I mean, of course, you can think about servers and very high intense compute platforms, but from a way to experience entertainment, for a way to do productivity, as humans, I think there's going to be nothing more, in fact, impactful than XR into our lives.
Yeah.
Right. The sense that you can have a screen with a field of view as big as your eyes.
Right.
I mean, where else can you have that?
Right.
A TV is not that big, a smartphone much less. So I think having that ability to have screens or virtual screens, wherever you want, how big you want, it's going to be really the next generation of compute that we as humans will have.
Yeah, I think it's going to be more compute intensive and extremely complex technology wise.
Yeah.
I mean, in the world of where we talk about computer vision and AI, if you think about anything under the mobile landscape, so there's of course this watch and this IoT products and this auto and XR, but the complexity of technology where you're trying to see if you can shatter physics in a way, or change, have really small batteries that sit next to your eye, and try to use as much AI as possible to just predict next generation use cases, right? I mean, it's taking complexity of this technology to a very different level. I mean, and it's the challenge that XR has that none of the other verticals might have in terms of how the technology is going is the devices have to get sleeker, right? Nobody's going to wear big, huge glasses. Everybody wants to wear their Ray-Ban and Oakley-like glasses, but at the same time, they want to have their technology that is promising that they're seeing on a phone and a laptop today. So to Hugo's point, yes, the compute intensive, but I also think one thing that we'd like our audience to take away is the complexity of technology is a lot. And that's exactly why Qualcomm's working on it, because who else would?
Yeah, I was just going to say, well, who are they going to turn to when they need
exactly.
complex technology?
There you go.
Right.
Yeah. So, I mean, and to that point, so if you're going to build an XR device, you need something that's going to show amazing graphics, that's going to have amazing sound, that's tracking your hands, that's tracking your room, that's tracking the body, that's doing all this stuff and crazy compute. So what have we been doing in this business? What does Qualcomm provide to help enable these things?
The way to think about it is understanding your own body or your own space in the environment and understanding the environment itself. So these are the two different components for that. But if you just think about the basics of these devices, it needs to be lighter, sleeker. It needs to be extremely compute intensive. And third, it shouldn't get hot. We don't like hot phones in our pocket. Imagine having a hot device near your eyes. So what have we been doing?
Oh, and wireless.
100%.
That's it, right?
Thanks for bringing that up. I wouldn't have a job tomorrow if I didn't. And of course, connectivity is a big piece for sure.
Yeah.
So we of course had world-class processors that we've been working on for the past decade or so. But our journey on XR began 10 years ago We've been working on AR SDK and a lot of other perception technologies, as we call
SDK,
it.
software development tools?
The software development kit, but a lot of software and technology that strengthens the hardware. So the perception technology, as we call, like anything to do with the tracking of the body or understanding the environment itself, and at the same time having, as you said, rich graphics, like amazing video, and at the same time make sure that the battery and performance of these devices is high performance, low battery, low latency. That's like a mantra. If you ask any XR engineer, product manager, anybody who's working on XR, you wake them up at 3 a.m. in the morning and say, what's the mantra of the XR team? It's like high performance, low latency, low power. That's all. It all comes down to that.
Oh, so now correct me if I'm wrong. I get the low power because you obviously want these things to have great battery life, and I get the high performance because you want good graphics and stuff. Now the low latency. Now when we talk about 5G latency, we talk about kind of moving in real time. So like, if you're connected to a supercomputer or a robot, you move your arm, you want your robot to move the arm, got to move at the same time. So it's the same thing with XR, right? Like if you have an XR device on your head and you're in a virtual forest and you turn your head to the left, you want to make sure that what you see actually turns to the left. And that's the low latency part. Is that correct?
Correct. So there are multiple aspects to it.
Okay.
The low latency is the latency within the device itself. So, for example, we're sitting in the conference room. Leilani's on my left, Hugo's on my right. I look at them left, right, I can see them. Mm-hmm. In the virtual world, if I'm wearing my VR glasses, I find myself in the middle of Manhattan. I look to the left, I need to see Times Square. I need to look to the right, I need to see the Disney store, right? But in AR, the latency also for 5G and connectivity plays an important role. If I'm walking, to your earlier example of Google Maps or navigation or even some AI information that herein, you like lattes, there's a good latte cafe right around the corner. That latency needs to be there, like really out there when you're talking to people or walking down the streets based on the use case. If you're wearing glasses, again, walking in New York or Rome and you see the cathedral, you look up and you might have an image coming up on your AR glass saying what are you looking at, when was it built, and any other information.
I would say that as much as possible, Qualcomm's role is here in regards to latency and all these other technologies is to close the gap between what we experience as humans in our reality and what you would see in an augmented or virtual reality environment. You want it to be simultaneous, just like you would see it in real life.
Cool.
And then, back to your earlier question on what at Qualcomm are we delivering, right? How do we put all these requirements together, the latency requirements, the graphics requirements, making it closer to a real life experience? So you can summarize, what we offer in XR in 4 key buckets, or we call it the 4-pillar strategy. Right? So the first one is, of course, our chip, right? The silicon, right? It needs to be the best silicon for mobile XR, right? And then when we say best, is power, performance, affordability, and where we're looking to under the hood, how to really make all that latency be reduced. How do we connect our GPU to CPU, the camera, IP blocks, and DSPs and sensor hubs and et cetera for the lowest latency, right? So, it has been a good 5 years ago that we started to think on how to interconnect, how to design chips for XR, right? 820 was the first chip that we said, meets the minimum criteria for good VR and AR. And then year over year, we see us improving our chip offering to this market.
Cool.
Up to the point that last year we announced our first dedicated chip for XR, the XR1, right? So I think that's the first pillar, the chip.
Cool.
Second pillar, right? How do you make these perception features work on our chip? You have all this cool hardware, but how do you make it available to our customers, developers? So we have a software package, right, where we have the specific technologies, right? 6 degrees of freedom, that's another famous term in the XR space, right? The way you track, right, your movement, that's one of the top, features for that we need to make available on XR devices.
So wait, so correct me if I'm wrong. So I have a pet peeve. We got to define every little term we throw out there just for the audience. 6 degrees of freedom. Could I take a stab at trying to define this thing? How about I define it by taking a step back? 3 degrees of freedom.
Okay.
Sorry. So that's tracking head movements.
Yep.
And it's pitch, roll, and yaw. So basic.
Whoa, PJ.
Hey,
I think we have an opening in the XR team.
Hey, let's go. All right, we'll talk to you after.
No, we don't.
I've never been hired and fired in 1 second. That was unbelievable. Yeah, no, I've started all these messaging documents. So basically, pitch, roll, yaw. So moving as Lani she gave me the answers right there as I was looking at her. So basically, move your head left, right, up, down, and then kind of on an angle, right? Is that kind of, I don't know how to make
That's
the angle.
the 3 degrees of freedom.
That's 3 degrees.
Like, going back to Hiren's example of Manhattan.
Yeah.
Right? I'm in the middle of Manhattan, and I can turn my head left, right? See McDonald's on the left, see, something else on the right. And then let's see your explanation on 6-off.
Okay, so that's what I was going to say. I wouldn't be able to do it as gracefully, but I think if 3-off is the head tracking, 6-off is body tracking. And I know there's a next level of body tracking after that.
Right.
But I guess simple, you would be giving you the ability to maybe take a step or two in each direction. All right, give me the better answer.
See, the Manhattan, what would you do with 6-off if you are in VR in Manhattan?
Okay. I think maybe if I see a sign, I could take like a step closer to it. Or if I'm outside of how about I'm outside one of those pretzel stands.
Right.
Maybe I can take a step closer, see the grill, see the menu, see the prices, turn around, maybe walk around the stand.
Right. And that's exactly it. And then...
Or if there's a cab, you bend down and hail a cab.
You're right. There you go.
I think there's no limit on, it needs to be just, a few steps versus a lot of steps.
Right.
It's really that in fact, you're going to be in a VR headset and you're probably going to be within a room that, you cannot, walk that long before you hit a wall.
Cool.
So together with the 6-off tracking,
Yeah.
you need other features like boundary systems, right? Detect a wall. Well, tell the user, don't give one more step, otherwise you're gonna hit the wall, right? So having kind of a grid system that identifies up to when can you move. So
you
going
can
back,
safely operate in VR.
exactly. So all these features, right, are part of our second bucket of deliverables to customers and partners. Right, the first is the chip, the second is the software. Third is what we always, actually since the 820, right, the first chip, there was...
The Qualcomm Snapdragon 820.
Right, exactly.
So it was something that was designed with smartphones in mind, but as we saw, to your point
already
earlier,
optimized for XR.
Yeah.
But, okay, so people are used to making phones with these chips. How do you make a VR headset? How do you make an AR headset? So what we do is we create a reference design, right? So we create a reference design that, the name says it all, is just a design that is used as a reference by our customers. Right? It is going to have the form factor of a head-worn device, but we put
If you were a consumer though, and you saw this thing, just so our audience gets an idea, we keep saying reference design, it's guidance to what things. If they just saw this, you guys built an XR headset.
Yes.
A fully working XR headset powered by a Snapdragon processor.
May not look as sexy or as good as a customer or a final product, but it has the the right size so that one can take it.
Right.
One meaning a customer of ours can take it and quickly build a derivative of it.
Cool.
Right. They always tweak a few things, and then. But then with the reference design, we put the chip and the software together and then build a network of partners like ODMs, right? And camera module partners and so forth, so that it is as close as possible to an end product.
And I just wanted to point that out because just as a tech enthusiast, when I see these things years ago when there's no XR headsets on the market, and all of a sudden I walk over to someone's lab and all of a sudden there's an XR headset sitting there. It's mind-blowing, that this isn't on the market yet. And then this is something that we're building internally so that we can help others build it better, faster, and get it into people's hands quicker.
And I think it's not unfair to say that we actually came up with the standalone VR headsets with our reference designs. If you look at our announcement at IFA 2016, when we showed the first, reference design of 820, there were no products out there, right? Comes 2017, well, you start, seeing a few of the big companies, proposing solutions like that. But I think we were the precursor of what today is, I think, agreed upon as the best form factor for VR.
Awesome. And and just to give us more props, I mean, Google got on stage at Google I/O
2017.
There you go.
Right.
And they said they're like, we're using Qualcomm's reference design to create an XR device.
Yes.
Period.
I remember where in meetings with all our big partners and companies, the product that Hugo spoke about, the 820 standalone reference device and the 830 standalone reference device which we built, which is now, 835 Oculus Quest has it, and the HTC Vive device has it. The Lenovo Mirage Solo with Daydream has it. But think about it, that 3.5 years ago is when we had these reference devices, and we were practically on a plane around the globe as well as in the US showing this to customers, and we'd see that aha moment with some of these big partners and say, wow, we can make this, like, as Hugo said, these were not the most sexiest devices we were building, but the functionality of the blueprint of these standalone devices were phenomenal. And this was when
possible.
Yeah. And this was still in the time frame where watches were becoming a big thing. Because 2016 was eons ago, right?
Right.
3.5 years ago, the tech industry was very different. AI was still becoming a big thing then. The machine platform crowd was still not becoming the big thing. And that's when we were showing these devices. And now, 2019, the standalone reference device of, or rather, the 835-based standalone device, Oculus Quest, is the best gaming device as per Amazon. So it's pretty awesome.
That's awesome. That's crazy.
And so now getting to the fourth bucket.
Go for it.
It's really partnerships and ecosystem, right? We ourselves, we know what we deliver, right? And it's really the technology, the chips. We don't make end products. We don't make content. We don't make app stores. But for someone to buy this product, you need that. So that's why we work with so many players in the market, almost providing this horizontal technology and processors, so that this different, be it an end OEM or a platform provider, can connect to Qualcomm and make their own spin of the offer, right? With their own app store, with their own go-to-market strategy. That's kind of the fourth pillar.
Cool.
One example of that I always like to highlight is what we have done, for instance, with HTC Vive. I think you mentioned here in Oculus and Google, but HTC Vive also work closely with them, in particular in China, right? Because Google and Facebook, they're not in China, and still. Going back to the 2016, 15 days, It was like, okay, so you have 20 companies in China trying to do hardware, and each one, trying to do their own app store, their own ecosystem. And I said, well, that's difficult to scale. And then we worked with the Vive guys and said, hey, I know you have your first-party product, but what if you also use, your platform, the Vive port, and create a new SDK, the Wave SDK, that can span across OEM or hardware manufacturers in China. Mm-hmm. So that's, I think, a good example of...
It also became wireless.
Absolutely.
Yeah.
Right?
Yeah.
It sounds like you guys went in there like, hey, we know you have an XR helmet that has to connect to like a $3,000 PC with a wire.
Which has great experience, by the way, but at the same time...
Right.
Our forte is true mobility.
Right. Well, not even that, but I think, if you look back at that time frame, it's not that VR didn't exist. Right. I think their first foray into VR might have been Google Cardboard, right? Yeah. You take your smartphone and you slip it in, and now you've kind of got a ad hoc VR headset. Or on the other side were these other PC tethered, which were cumbersome, they were expensive, it wasn't scalable. But as we know from Qualcomm being a mobile company, VR must be mobile. For you to interact with an environment, you have to be able to walk around in that environment, interact with that environment without having that. And the price points today have really made it scalable. And so from either a consumer level or enterprise level, you can implement it across many, many, many people.
Stay tuned to our next episode in which we'll continue the conversation on XR.